Hi, everybody. I'm Sean Benjamin. I'm with the USCIS, Citizenship and Immigration Services. I am the Chief of Data and Business Intelligence. I've been working for USCIS since 2006, and we have created the first enterprise data warehouse within USCIS. And I am here to talk about our journey to our modernization with using Databricks and cloud services. So what we did coming into the cloud in roughly January of 2016, and we knew we were bringing some problems in with us, and the fact that we're moving data. So we had a few problems that we were facing. We're using ETL, informatic ETL, and the pipeline was fairly brittle, and it's a lengthy development cycle, and the workflows were longer, and we were really lacking that real-time ability and near real-time, term I like to call relevant time data, and truly lacking a data science platform. So we knew where we were going into the cloud, and we knew where we wanted to be. So the real question we had to ask ourselves was, how do we get there? So we were bringing this legacy architecture in with us. So we were bringing, source system data in with Informatica, putting it into our data warehouse, which is Oracle based, and we're still running Oracle to this day. And then presenting that data through Oracle, OBIE, which is a product that we've named Smart within USCIS, and SAS. We did have some data scientists, and they were extracting data out of those tools, bringing it to their laptops, running their R and Python code, and trying to do data science activities, with low computing ability, and definitely not within the enterprise vision. We had already a pretty good wealth of business analysts and statisticians using SAS and Oracle. But we knew coming into the cloud that we were bringing this environment, which we're very proud of. As you can see here, we had about 36 data sources, 28 ETL process, 2,300 users. And we did this, and this was an evolution that roughly took 8 years to obtain. But once we moved into AWS, we knew we needed to expand, and our user base was expanding as well. And the speed of their growth was definitely driving where we wanted to go. So we started doing some research. When we first went into the cloud, this area where it's called ESIS score that you see on the bottom left side of your screen was all within Oracle. The smart subject areas above that being OBIE, and you see the SAS library to the right. We moved data into the S3 format, and we were not that successful with getting it out to the users timely. And we were starting to, just starting to learn it ourselves, and what it meant to get data from a data lake, which is something that we were very interested in moving towards. We needed a tool to get there. We had a solutions architect at the time, and we started digging in and doing some research, and we discovered Databricks. And the light bulb really clicked for us on what we needed to do moving forward to stay relevant. So we built a successful proof of concept, bringing in Databricks. We brought in, into our VPC, we went to a 26 node a setup where we were trying to attain these 4 objectives of how we could support basically what our current mission was and still move forward. So obviously we needed to connect to those Oracle databases. So we connected Databricks clusters to those databases, created the relevant hives that we needed, started copying the data in. And for context, we were seeing these big improvements right there, where we were saying, bringing in these 120 million row tables into S3 from Oracle using Scala code within Databricks within just 10 minutes. And I think our Informatica timeline on that was somewhere around 2 to 3 hours. We needed to identify the appropriate partition schemes and obviously create multiple notebooks. This is where we started to want to get it out to our user base. And have them start to take advantage of seeing the ability within the product through a lengthy amount of time. we basically came to what our current implementation is right now. And as you can see, with Databricks and Spark sitting alongside of Informatica as our ETL tool, like driving data from the sources, various sources, whether it's Kafka topics, Oracle database, or PostgreSQL databases, into the data lake, as well as being able to source from both directly through Databricks or from the lake within our user interface tools such as Tableau, which we've recently procured, OBIE and SAS, and plus having a wealth of users within the Databricks notebooks, delivering capability to multiple groups from a single point, and not having so much of that swivel chair activity going on. One of the things that we did do in our implementation as well was we decided that we needed to bring our entire data warehouse into the data lake. That way we could take advantage of all of our interfacing tools within all of the data that we had in USCIS. So what you're seeing here now is what we look like after roughly 4 years of being in Amazon. We have ballooned from 30 something data sources to 75 data sources with 35 application interfaces, multiple marts, tripling the size of our user base because the capability has been driven. So everything you see now at the bottom of this slideshow is the enterprise data lake for USCIS. And then we've still retained our Oracle platform. And what we're doing right now is when we first started with Databricks, we were trying to bring the data from the sources in Oracle into the lake. We realized to save cost and the speed of ingestion is so much better to go right directly to the lake. We're starting to reverse or re-engineer that flow of data, that ETL, of moving data from the source to the lake and then to Oracle if we need to. We can access the data lake with all of our UIs. And many of those are taking advantage of going through Databricks access our lake. So Databricks is sitting over that S3 storage area. And what we're also doing now is building our data marts and our warehouses directly into the lake. One of the things that I've really appreciated, and you can see like the speed of where we've been able to grow, is that Databricks has given us that capability to analyze data or move data quickly and understand more about that data in a quicker fashion. And some of the success stories that I talk about when I talk to our customers, as I'm getting them to change over to our product, is the ability to fail quickly and recover. When I say that, we're able to have teams. We brought in a few teams from around the country to build a product we call the National Production Dataset. Is in older tools, as they were using SAS to start, it was taking them a day to find out that their logic was not right. So they would build this logic, they would run all the data through the logic and find out the logic was right. Within Databricks, and this is a real story, we ran a very complex query through Databricks, went to lunch, came back, 19 minutes, it's done. And the team had realized that their logic was incorrect. So what would have been an 8-hour loss was a 19-minute loss. And you could really see the data analyst and the business analyst in the room like saying, wow, this product just saved us so much time. They could re-engineer what they were trying to build, try it again and see successes. We've had similar stories of just taking some larger SaaS logic where it was taking 4 or 6 hours within SaaS to run to build what you could call just-in-time warehousing, moving it over to Databricks and taking, I think, 10 minutes and actually being more accurate. So those capabilities have been starting. We've been able to take those stories and bring them out to the user community, and now a lot of teams are starting to build within their own data ponds inside the lake and expanding that out to the enterprise. So through Databricks and the accomplishments that we've seen in this relatively short timeline is With the implementation of Delta Lake, which Prabhu will talk about a little bit later, the ability to insert, update, delete, which is a huge operation for any IT organization, be able to bring that into the lake and have that ability with Delta Lake and what that brings to the teams. The ease of integration with our tools was key. Of having all those native connectors with OBIE and SAS Tableau, it's made things really easy for everybody. Integration with GitHub for our continuous integrations and deployment. We're continuing to work on automating our account provisioning with Databricks. That way we're not spending less time creating accounts. We've had a lot of requests as of late. The tool has really took off for us, especially since we've gone into this last bubble here, machine learning in our MLflow integration. Within USCIS, there's multiple teams outside of our direct team that have gone down the road of building out large ML projects and experiments. So I'm going to hand the presentation over now to Prabhu Rajendran, who is the lead engineer on our team and implementing and installing capabilities through Databricks.
Thank you, Sean, for that introduction. I'm Prabhu Rajendran. I've been with this USCIS program since 2013, and I also got the opportunity to start and do the POC and get the groundwork for Databricks and get going. And wherever we are today, I was also part of this journey. That's my privilege. And getting on to the technical aspects of what we have done, whatever Sean said in the previous slide, some of the accomplishments which we have done so far. In that, the first comes the change data capture, where when we started this journey, we wanted to replicate the data from the Oracle targets into the lake first. So how can we do this? So we just made sure that there is a pipeline or a fork for an extra target where we can load all the data into the lake through Databricks using Scala code. And that's where we started this as a simple code. You can call it as just pull and push that data into the lake. So at least the BI application users will start using the data lake going forward. That's how we started. But how can we do how can we keep up with the change data capture, what's happening, right? If we have to have a near real-time replication, how can we even accomplish this? Especially 2-3 years before, where Delta was not there, or it was not so popular at that time. Then we started everything with, we have to insert all the records into the lake, and then we have to do a rank function to do the deduplication as well as to show the unique value for that particular record so that the reporting will not be affected the same way. So they transition from the Oracle to the lake is seamless. So that's how we started. That was a tedious way of coding for us. But Delta Lake, which was introduced with all the enhancements that has been made so far in the Delta Lake for all the insert, updates, and deletes to be captured, made our life very easy. So we can use any of the streams like the Kafka or Kinesis or even AWS DMS, anything to land the data into S3. And then from there, we wrote a framework in Delta. So all the data will be stored in S3 as a Delta Lake. So that's how we transitioned. So what all we gained out of this is, one is the users who are reporting off this Delta Lake, they will not have latency because the inserts and the writes were happening at the same time, and there was no there was no latency for the users to retrieve these records. That was one advantage, and also there was a fast ingestion of these CDC changes. Then the quality of the reports, which they were going against the Delta Lake, the performance was improved. That's another thing. And if there was any schema changes back in the source system, it was very seamlessly replicated. Also, the failures were gracefully tackled. So these were some of the advantages which Delta Lake as such had it in its product, we kind of utilized that in our program and we took forward that. But yes, what all we learned through this process when we implemented Delta Lake, some of the things which we did not pay attention to was the vacuuming. We kind of initially, when we started this experimentation with Delta Lake, so the vacuuming was something which we kind of accumulated for a month, and we still had our own hiccups when the logs were too huge and it really broke down our system. So vacuuming is one mandatory thing, which we now have a 7-day retention period, and even sometimes 2-day retention period if the volume of the incremental for the CTC is more. So we kind of made sure that vacuuming is also part of any of this Delta code framework. So that is one thing we learned. And also one more thing we noticed out of this Delta was the storage requirement obviously increased on our end because we keep the logs aside. So that's how we kind of modernized the change data capture into our program. Let's talk about once the data is landed into the lake, how did our applications connect, and how did our applications connect to these analytical platform? The applications connected to the lake. So that's where comes in Tableau. These are some of the dashboards which we wanted to show what we have implemented so far. And the connectivity initially when we started Databricks, when there was no inbuilt connector available, the native connectors available, we kind of utilized the ODBC Simba drivers to fetch data from the lake into the Tableau. And but now because the Databricks has its own native connectors, this has become even easier for us, and the performance for extraction of data into the Tableau servers has become faster. When I'm talking about the faster performance, there is one more milestone which we achieved was the Hyper API. The concept of Hyper API, which helps us to extract data faster in the notebook in the Databricks and then publish that to the server. So the reporting end will not take that strain. So that was one of the bigger milestones which we have achieved, and that helped us to even refresh data in a faster rate on the reporting end. This is another example of the OBIE and SAS, which we pointed to the lake from the data which was loaded through Databricks Scala code. OBIE and SAS, before it was pointed to Oracle targets. What we noticed was some of the queries, which were some of the dashboards which are created in OBIE, which was performing say around 15 minutes runtime, or sometimes those dashboards would not even return the results because of the load which was given on the Oracle database, and sometimes the queries used to churn for a longer time and it was not coming. But whereas when we ran the same queries pointing to Databricks, the query or return was under 15 seconds, 15 to 20 seconds maybe. So what we noticed was the performance was drastic, and the number of failures or the query always came back. That was consistent. So that is one more thing we had advantages in pointing our data to the lake, especially our existing dashboards, which were pointing to a database, to a lake where the data is underneath is being written through a Delta Lake. Going to the next, what did we do on the data science field? This itself will be a bigger discussion for us, but let me brief down whatever we have done through this journey. How did we start was we started taking a particular use case for USCIS especially. We wanted to say, we wanted to just determine or predict what is the probability of people not showing to an appointment, and why do they not show up to an appointment for a biometrics appointment or any appointments which they have with USCIS? Why do they not show? What is the prediction? How can this be avoided, or what are the prediction factors which is causing this no-show in an appointment? That is a simple use case which we took. How did we move ahead with that? Is we used R and Python in the backend, and we used some of the inbuilt libraries to munch the data, and we had the data with we divided the 70-30% rule, and we run those data through the prediction models to predict whether the location of a person or the lead time in which the appointment is being scheduled, these are the factors even causing this kind of no-show for a person to not show into an appointment. So these were some of the prediction models which we did in using the Databricks platform. And we did not stop there. We also took that model and ran it through our MLflow with the runtime clusters which we have with Databricks. We kind of used that and we ran end-to-end on an ML model to see how this can be predicted and how this can be run through a model to see what is the pattern we are saying. As a next one, also we took another level where we wanted to analyze or do some analysis on sentiment analysis of any of the survey data. So this is one of the example which we are showing here is one for text and log mining. On the text mining, we just wanted to see what is the sentiment it has in a particular set of data. So that prediction was done using R in Databricks, and we were able to do this in a very short period of time, in matter of a day or two, to predict to give the sentiment analysis results. So it was so quick because all the inbuilt libraries in Databricks helps us to get these results. And also we also did some log mining to get into see how the performance of any of the systems are doing, or how many users are logging in, and what is the frequency of a user logging in. All these kind of things from the inbuilt data log what we store in S3. We wanted to do some prediction on that, so we did some log mining as well as part of our experiments. Whatever the model which we created, we also did the time series to predict how many number of applications will come in the future years, or what is the pattern, where was a dip, where was a high, and how many recipients are even applying for certain kind of applications. These were also run through the time series models. And what we did was we kind of ran through all the algorithms, like the rainforest regression models or logistic regression, all these models, and we predicted which will be the best, which has the better accuracy. Based off that, we kind of predicted the same models which we had done it in a previous library. We kind of managed to do that this year. And also there was one more thing called the H2O integration. H2O is another auto ML available with us, which helped us to integrate within Databricks seamlessly. It was just an addition of a cluster to the existing cluster, and addition of a library. So a library to a cluster, and that helped us to utilize the H2O also as part of this experiments. So let's get back to the security and governance part of side. So once when we were shifting our mindset from the legacy to the data lake concept, we wanted to maintain the same privileges and ACLs for all the data system data sets which we have in our lake, so that all the same roles and privileges are maintained. So this Databricks with its inbuilt ACLs and ACLs, we were able to do that. And also we maintained a credentials credential secret management, where we had a secret manager to store all the credentials and reference them in the notebooks. So that was some of the available features in Databricks, which we utilized as part of our system. And also we created the exact IAM rules, which are required on the S3 bucket level, as well as the ACL rules of the Databricks to have this security and governance for any of the data sets we have. On the Databricks management API usage, so this being an inbuilt feature with Databricks, we were able to create any number of clusters or jobs and monitor them on a daily basis. And we also integrated with Airflow to manage it and orchestrate this monitoring experience. So this is one thing which we utilized, as well as with its libraries. anything can be reproduced in your notebooks using the existing available list of libraries. So that was easier for our machine learning and data science team to do any of the programs which would have taken long number of time and which would have taken more time for them to even code all that through instead of attaching to a library. So this was more easy for us to do that. And also integration and deployment. We integrated Git automatically. We did the configuration of Git with Databricks, and that was an easy sync for us to enable for us to sync all our changes, and also it helped us in our continuous integration and deployment perspective. Apart from that, the last one is the MLflow. MLflow is a bigger milestone for us, and we are able to run these models in using the MLflow clusters, and the API has been helpful so far. That's all I had for today. Back to you, Sean.
Thank you, Prabha, for filling us in on the work that you've done over the years. It's been a tremendous amount of work, and we've had a tremendous amount of accomplishments. So what we want to talk about in the last couple of slides I have for y'all are the lessons that we learned. And it's just kind of a culmination of things that we found along the way. And one of those things is absolutely building a training plan. We at USCIS still didn't fully grasp what data science was when we brought this product in. So we were trying to learn that ourselves. So we actually went through the training ourselves to use the product and the tool. And then we brought in, I think, maybe 30 people from around the country in different offices to actually go through the training. And some of them were advanced and they were able to grasp the concepts just fine, some not as much. So at that moment there, we decided that we needed to work harder with our user base and build our own internal development plan for our users. Like with any place of business, training within your own data sets is always very big. It helps the user base to realize the power of the product. We're actually in the process right now of building a customized training plan alongside Databricks and training and support that will suit the needs of our mid-level to advanced users, especially as a lot of shops have now started to grasp onto Databricks and they want to move their code out of SAS into Databricks. So building a little bit more customized training, it's allowed us to actually build a stronger connection with our users. The cloud-based experience through this tool has become fully realized for us. Where we thought moving into the cloud immediately, like anybody has been sold anything, was going to be immediately fast and ease. It wasn't until we brought in Databricks we could really grasp onto that. And I think I showed you that with the ability to expand as we have becoming so scalable. Not only did we expand the amount of products we're delivering to folks, we expanded the knowledge base within our own team. When Prabha first was on the first wave of folks to use the product, I think that caused a lot of drive from other members within our development team to want to learn the tool and learn the product as well. And through that, we brought a bunch of Informatica ETL developers, OBIE developers into learning how to use this tool. Prabha was on the first wave of learning how to use the product and understanding it. She trained the second wave, and now the second wave is training the rest of the wave of our team. We have a lot of folks within our development shop that are experienced within the tool and know how to use the product to deliver. Subject matter expertise is also very important, and not just subject matter expertise within Databricks or within cloud computing, but the data. And it goes back to the training plan. The more you can realize the data and what the product is allowing you to do with the data can really unlock some very powerful stuff. So as we started bringing our subject matter experts of the data into the product, training them how to be at minimal proficient with the product, they saw the value and they started becoming better, and in turn have started to become subject matter experts within the tool itself, not necessarily coming to IT for support, but going to each other. What I like to call tier zero, ask your friend, and they may know the answer and they may be able to help you along. And that's when you start getting that type of organic ground roots support within these tools, it just makes everything easier for everybody, and it aligns your business to your IT. And the automation is unbelievable of what we've been able to accomplish there. And when we're talking about automation, not just automation of jobs and the automation of data and how it can work for you, to save costs within USCIS and within Amazon, we do turn back a lot of our servers overnight, and in off hours, we've been able to build jobs in place where developers can go in. Everybody is remote, and especially right now, we're all very remote, working on different time cycles. They can go in, turn the environments on, work their data, turn the environments back off. Being able to allow folks to do that, as we've seen some major cost savings. And eventually, we really want to, get to the point where we're driving a lot of the automation within the tool, using machine learning and operationalizing our machine learning models to do the tedious work where we can be saving the time of the human element and refocusing that workload somewhere else. So as we implemented Databricks, we built a success strategy, and we hit every point of our success strategy, as you can see here. So the first thing right away, performance, obviously with the ability to scale and leverage on-demand and spot instances. Being an Oracle guy in the past where we didn't have that ability, we immediately saw benefits right there. And the scalable read-write performances that we had on S3 were amazing. Support for the variety of statistical programming languages has been huge for USCIS. The bulk of USCIS users are SQL developers and SQL programmers. So being able to slide them into the tool, at least with that language, and we did have a lot of R and Python users as well, but they were able to learn multiple languages, work in a singular notebook, and move between the languages. As the agencies heard us talk a lot about Scala developing, as that is our main code of preference for ETL. We've driven some benefits of showing that the power of that language to our users, and now those users are actually looking on getting more familiar with Scala and taking training on that. The ability to work in so many languages actually opened up the diversification of our analytics community as they moved into Databricks, and obviously the machine learning and a deep learning within those tools of how we've been able to take that concept of moving data through a machine process into outcomes where we can start to take a tedious job function that would have been done manually at a clerk level or a singular person level, move it through the process and the ability to derive direct value from that. And you can move those resources now from a more tedious task into other areas of function. The integration with our existing tools, allowing connections across all the tools that we have has been very, very big for us. Having so many UIs now with OBIE, Tableau, and SAS, we are able to integrate the products with each other. What we try to focus on and getting our user community to do is do your just-in-time builds and your just-in-time warehousing on the Databricks side. Build the data, do your heavy lift there. If you're more comfortable with using SAS or you're more comfortable with using Tableau, do your heavy lift within Databricks, build your data sets, and then use SAS, use Tableau to analyze and work that data. So this wraps up our presentation. Thanks everybody very much for allowing Prabha and I to share our journey with you. And at this time, we can field any questions you guys may have.